So we're going to analyze the forces that acts on a car that's turning in a horizontal corner. So this is a bit like a roundabout, but this is also applicable to a road that's coming like that, and then you have a bend. So this is a circular motion, and we have a centripetal force acting towards the center, and that centripetal force is provided by friction. So that means we have a friction force is acting towards the center, and that is the force that keep the car in a circle. So what will happen if we don't have a friction force? If we don't have a friction force, the car will continue in the direction which is tangent to the circle. So let's look at a typical scenario. You are an engineer, you're working for a council, and they're talking about a road that goes like that, and it turns here. So the cars go and turn, and they do a circular motion here. And they give you something like a friction between a car and the road, and they want to ask you that what's the maximum speed at which the car can travel on this road. So, which is a valid question, right? As an engineer, you want to tell them that, say, for instance, 40 kilometer per hour or something like that. So the only data you have is the friction coefficient. So that's what we are going to analyze here. It's something similar to that. We're going to find out the relationship between the maximum speed and the friction coefficient by analyzing the circular motion on a horizontal corner. So let's look at this one. Here we have this is the back of the car. So this is the back of the car, and this is the top of the car, and this is probably the number plate of the car. So we have the friction force acting this way, and weight this way, and the normal force, which is opposite to the weight force. So let's write the equations using the Newton's second law. So if we resolve the forces vertically, so then we know that Fn is equal to mg. Fn is equal to mg. And horizontally, the friction force is the one providing the centripetal force. That means F is equal to m v squared over r. So r is the radius of this circle. So in this case, r is this one. So that's the friction force is mv squared, because v squared r is the acceleration. So this is the acceleration, and that m is the mass. But we know that the friction force is equal to mu, which is the friction coefficient, time Fn. So then we can write mu Fn is equal to mv squared over r. So what's Fn from equation 1? Fm is equal to mg. So that means mu mg is equal to mv squared over r. So what will happen is that m and m will cancel out. So we get an equation of v squared is equal to mu gr. So that means that our speed is depending on the friction coefficient and the gravitational acceleration and the radius of the circle. So this is the important equation that we got from this. So as you can see, the maximum velocity that the speed the car can travel in a circle with radius r, it doesn't depend on the mass of the car. That's very interesting. It doesn't depend on the mass of the car. And also you can see that if we have a bigger radius for the car, that means you can go at a high speed. And if you have more friction, then also you can go at a high speed. So the speed at which you can travel on a roundabout depends on the friction coefficient and the radius. So now coming back to the question that we talked about before, about the council asking you to design or give you the maximum speed limit, this is what you're going to do. So you basically need to find the radius of this arc here, and also they are giving you the mu, which is the friction coefficient. So you put those values here, and g, we all know that, so you find the speed.